Hi, everyone. We're very excited to introduce you to Dr. Sam Cooper, leading researcher at the Dyson School of Design Engineering at Imperial College, with a focus on material science and next generation energy storage solutions. Dr. Cooper's work bridges the gap between computational methods and material design, aiming to solve some of the most pressing challenges in energy storage technology. He's worked on innovative approaches to enhance battery performance, which could have profound implications to sustainability and energy efficiency. Thrilled to welcome Dr. Sam Cooper to discuss his journey, his research, and the future of energy storage. Welcome to the podcast.
Thank you so much. Very happy to be here.
Yeah. Are you happy calling us Dr. Cooper or Sam?
Sam, please go for Sam.
Sam, then we're going to continue going with Sam.
Shirosh and Alex, right? Is that right?
Shirosh, yes, indeed.
Shirosh and Alex. Yeah. So let's start off. Could you just give us a bit of your background and how you kind of got into material sciences and energy storage?
Sure, absolutely. So I have actually been at Imperial College since 2008, so a long time already. And I originally studied mechanical engineering, which I enjoyed somewhat, like I had the kind of technical rigor of it. And I started off studying mechanical engineering with nuclear reactor physics and was quickly kind of like diverted away from nuclear, as there's this sort of sense that it wasn't going anywhere, which was really upsetting because I was, had a very idealistic view about it at the time. And a big part of the problem seemed to be about materials science. Another big part was about risk and manufacture, but there was already this sense of like, man, getting the materials right for this problem is really hard. I then did a master's, finally a project with my favorite lecturer. I think that's a piece of advice from the very start of like, if you're not sure about what project to do, I think picking an inspirational teacher to do it with is probably more important than the project itself often. And he had some work around understanding the relationship between microstructure and the kind of transport processes going on inside it. So this could be for things like catalyst beds or battery electrodes, which is where we're going in this conversation, or anything where you've got kind of like microscale features where you've got different processes going on inside each one. And I really enjoyed that project. I had a great time. And through that, I got in contact with a new lecturer at UCL, and he was interested in this topic as well. He'd got the imaging data and wanted someone to do the simulations for it. So that kind of grew from there. And then I was offered a PhD from two professors at Imperial saying, like, this is exactly what we need for the next stage of our kind of battery design, battery characterization workflow, except for it was actually about fuel cells, not batteries. So this related technology that you might be aware of, where often you're using hydrogen as a fuel. So they're kind of like a battery, but they're like an open battery where you keep pumping more fuel and air in rather than being this closed cap. So I did a PhD on hydrogen, high temperature fuel cells, solid oxide fuel cells. But a lot of the same theory, a lot of the same electrochemistry and this microstructure connection was the same for that as for batteries. And by the time I was finishing up my PhD, the battery hype train had really started moving out of the station, and a lot of fuel cell people were moving towards batteries. And the thing with batteries, and I guess all electrochemical devices, is that they require an extremely broad range of expertise to like fully understand the device. And so you need people who understand like the arrangements of atoms in crystal lattices to understand which materials would be able to maybe store more lithium or move more oxygen ions through in the case of fuel cells. You also need people who understand interfaces and flows of heat and electrons and ions. And then you need to understand how like devices fit together and how you make them in a reliable and predictable way. And how do you predict lifetime, and how do you then turn that into a device that will cost an amount that people can actually buy? Like that's a very, very broad range of skills.
Full life cycle.
Right, exactly. And what's cool about that is when you start doing battery research, you become part of this community with a very, very broad skill set. Yeah. And that's already quite exciting because there's people who have skills that you have absolutely no idea how to do, but you need to find a way to talk to each other in order to get the information to move up and down the supply chain.
So from a learning experience, right, that's obviously exponential. And I can imagine if you focus on one element, your specialty, right, which is why you were asked to join this big piece of research, to then all of a sudden get an overview of this whole life cycle. Does that completely open up your perspective of the impact that the work you're doing has on the world, on
I think,
sustainability.
yeah, I think it does, but that comes with quite a lot of anxiety, which I think a lot of people
Mm,
feel at that exact stage of their career, maybe for the rest of their career, but where you're suddenly like, ooh, I really don't know very much stuff. And that was particularly obvious for me leaving mechanical engineering and joining a materials department where I didn't know any chemistry. I'd done A level, but that's where it had stopped.
mm,
And so suddenly I'm sitting in weekly group meetings where everyone is talking about, like stoichiometry and reactions, and I didn't know anything about any of those things. But essentially, what you have to do, and what I hope everyone who does a PhD ultimately gets to experience, is that you kind of have to just take yourself off and teach yourself
yeah,
those things. No one's going to teach you, so you just have to go and learn them. And we're lucky to live in the
yeah,
age of information abundance, so you can just go to the internet and you will find incredible free online courses from the best institutions to teach you all about solid state chemistry. So I went and did Professor Don Sadaway's solid state chemistry course from MIT, and that's just freely available online. I think like millions of people have done this course, and that gave me all the foundations I needed to understand just at least just the language, so that when I could go to a group meeting, I would understand the words that people were
yeah.
saying. And that's a first step, but it's a massive first step, and it gives you the confidence to then start engaging in some of these conversations. So it does give you that big perspective, but that comes with a lot of
Mm,
anxiety about your
yeah,
own level of understanding.
Can I ask there in that? So far you told us right that how you started in mechanical engineering, and then it was a long kind of, if you don't mind me saying so, a bit of a windy road to to completing a PhD. Now you're kind of, I would say, you have a breadth of knowledge about many things. Would you say, now looking back, looking at the knowledge that you gathered at using doing mechanical engineering, but not knowing, let's say, chemistry, but the amount of work you had to do, which of course, it was probably stressful. It was a lot of, like, I don't know what the hell is going on, so I needed to learn. Do I know enough? It's a problem that I can personally kind of maybe think about as well, because when I was doing my PhD, I had the same issue. The My question is, do you feel now looking back that doing mechanical engineering, or if you had more information, I wouldn't have done mechanical engineering, I would have done something else, and then because I would have learned a lot more, versus, you know what, actually the doing mechanical engineering was a good thing,
mm,
because now I know, even though I might not have learned chemistry, but now I know about thermodynamics, I know about how things work in a system in a correct way, or whatever it is, right? So do you feel, let's say, the question I would say is a slight regret, or do you look up upon as a positive thing? I don't know if that's a
There's so much in that question that I care about deeply, and let me try and answer it with two different threads at the same time. Sorry, my cat is scratching so bad.
no,
um, One is that, yeah, I think in some ways it's kind of fine. Like if you go off and do a rigorous course of education on not necessarily any topic, but like quite a wide range of things, if it's probably in the STEM world, it's probably going to end up being useful. It will give you confidence about like you've solved some technical problems. You can probably solve some other technical problems. I definitely felt a lot of frustration towards the end of the degree and when I started my PhD that I had not done very much coding. And I feel like that's a massive gap because I feel like coding has some quite profound stuff embedded in it that's not just about how computers work, but that's like how to think about problems, how to break
problems. Yeah.
problems. But I think, for example, I think mechanical engineering at Imperial now has a lot more coding than it did, 20 years
mm,
ago. I think people are catching up to what's more important in engineering today. At the same time, I do have a lot of frustrations with like the way that education is delivered in general. And I'm now
mm,
part of that machine and understand more about why it is the way it is. But there is a sense that perhaps, for example, assessments, things like exams and courseworks, they can deprioritize the learning in place of the testing, right? You put such an emphasis on these particular checkpoints where you get a certain amount of marks, and all of the emotional feedback starts to stem from, did I do well in this test, or did I do well in this coursework? When really the did I do well is a bit more abstract, which is like, did I learn things? Like, am I more skilled now than I was when I started that course? And that's harder to measure. There's a fantastic book called The Tyranny of Metrics, which is all about this exact topic across a wide range of disciplines, that as soon as you turn the measure into the target, you end up with really like pathological outcomes. So they give the example of, like, some police forces were told that crime was too high, so we're going to measure how many people you arrest. So they just start arresting loads more people, right? And that wasn't necessarily solving the problem, but they turned the measure into the target, and that created new problems. And so I think that there are some really fundamental questions that have become more visible than ever in the educational space about what it is that we're actually trying to achieve when we deliver a course, for example, because historically the information itself was hard to come by. The books were rare, they were in the secret library, and the knowledge was only in the minds of a few. But now everything's available online for free. What is it that you come to a university to do? And it had better be some kind of incredibly enriching experience. Otherwise, you're paying an awful lot of money for a certificate. I think we think about that in my department at Imperial, the Dyson School of Design Engineering. We try to think about that quite a lot, and there's a lot of coursework. And the students, I think, are sometimes a bit frustrated, like, oh my God, so much coursework, so much group work, so much presentation of my ideas. But actually, we strongly think that that's a much more authentic learning experience for your career going forward than just having sat loads of technical exams where you crank the Fourier series by hand. So I had frustrations. I still think they were ultimately quite good.
That's a brilliant answer. I would say the reason why also I asked that was that maybe another way to kind of maybe interpret what you said is there are no mistakes. Learn what you can, get as much experience as you're doing undergraduate, masters, get exposed to many people, speak to as many people as possible. It's not really about learning just for the exam, but understanding that broader view of why this is done. So when you go out into the world, in the case of, let's say, going out into industry or into PhD, then it will become much more useful, and there are no mistakes.
I think a risk is that we could go too far down that way, and that every course ends up being an MBA, where this is to be slightly rude about MBAs. I haven't done one. I don't know what's in them, but the reputation is that ultimately what you're doing when you do an MBA is you're paying to meet lots of other rich people.
Yeah, it's a network, right? You pay for
that's really the content of the course is irrelevant.
Value. Yeah,
and that probably is valuable. This is why people pay for it.
So would you say that, and again, the Design School of Engineering, Design Engineering at Dyson, I mean, has always, from an outside point of view at least, felt like a very practical approach to applying key, theorems or knowledge or new science into practice, right? I feel like that's kind of what the school is also very known for. So
great, I'm glad to hear that. That's exactly what we're trying.
Yeah, I mean, again, I haven't gone there, but I know people that have been there, and it seems like it's almost modernizing the way that we absorb knowledge, but again, use it into real world applications. Because to your point, you can study for exams, great, then you have it, and then nowadays knowledge is everywhere, right? So I believe that in the next couple of years there's not going to be a lot of value of memorizing stuff, because you could type something in and you could get it instantly. The value really comes from, okay, I have this knowledge, what do I do with it? Absolutely. And what you described is exactly that.
Yeah,
which is very cool.
There is an interesting paradox there. Paradox is possibly a little bit overly grand, but I actually now think that there probably is a bit of value in memorizing stuff, but not for the quick recall, but for the very fact that you have embedded it into your local machine. I think probably has some value in your capacity to view new information through this lens that you have deeply internalized. So you've not memorized it because you've set up a rhyme that means all the words stay in your head, but you've
Yeah.
memorized it in the sense that you can recall it very quickly because you've used it and are very competent with it. So you've not learned it, but you have the information deeply embedded. And during COVID, as an institution, we made all of our exams open book because we couldn't determine a good way to prevent cheating. So we said, okay, well, let's write the exams so that they're strong against cheating. And that was good. And I was really excited about that because I was like, great, memorization's silly. Let's get rid of that. Let's write really hard exam questions. And that has its own challenges. But then, 2 years ago now, ChatGPT comes out. And suddenly, open book exams don't necessarily look like such a good idea after all, because even some of the conceptual understanding stuff can be seemingly done by a machine. The models have just got better and better. Most recently, I've written a short document for the college to explain why we shouldn't allow open laptop exams anymore, because the models are just getting better and better. One could come out the day before the exam. Maybe only the rich students can afford to use it. So this is just not a reasonable way to assess things anymore. But it begs questions about what's the value of having something in your head when it's already in the machine? It's led me on this path of being actually, I think there's lots of value. I think having a very deep intuitive understanding of the Taylor series is profoundly important for being an engineer. And I hope that you're both nodding because you're like, absolutely, I fully. But of course, you could Google it in half a second. But having it in there makes me view lots of problems totally differently.
There's superficial knowledge absorption and memorizing versus understanding, right? You could memorize all math formulas and forums and all of that, but if you don't understand it in any other situation, you won't be able to apply it. So I think intrinsically understanding it is what allows you to then create a larger impact down the line, if what I'm hearing correctly.
And I would also add, at least this is my personal experience, I'm sure maybe there is something that to be said about it. Learn memorizing, or at least understanding it in a way that you memorize it, allows you to, at least my personal experience is that you're working on a problem, you can't really get through it. You go and for a walk or to do whatever, and then go have a sandwich or whatever it is. And then in that moment, because your brain is not working on that problem, you then think they make a connection. And if you didn't have that knowledge, or if you didn't effectively wasn't curious, and if you didn't understand, if you were doing it for a different purpose, you may not have made that connection. So I would say that knowing that information, those little chunks of information just rattling around, that's never a waste. I would say that's never a waste, because they will make connections in your brain, and especially if you're going down.
You're not wasting memory.
Yeah.
I think Sunday mornings are when I have most of the interesting ideas I've ever had. Sunday morning, lying in bed, thinking about things. That is the moment where I'll be like, oh, those two things stick together.
Correct.
For me, it's showers.
Right. The classic.
Shower. It's the classic shower. I wish I had a whiteboard in my shower where I have all of these ideas. I'm like, oh my God, I'm going to write them down. I'm like, oh God, I need to.
I wonder, there's some really interesting stuff that I'm sure we can tap into about the noise, the environment, and the fact that you're isolated. And it must be able to reproduce some of that. An experience that I had during my PhD that I think about quite a lot is that at Imperial, there is one of the world's top groups for psychedelic research. So they research, psychoactive substances in general. And this is Professor David Nutt and Robin Carhart-Harris. And they had put some posters up on the walls of the department saying that they were looking for volunteers to take, I think it was psilocybin, so magic mushrooms, and come and try and think about problems that they'd been stuck with for a while. And I was like, that's so cool. I'd love to do that. Yeah. But this was quite early on in my PhD. And it occurred to me that I actually didn't have any problems that were sufficiently deep and interesting that would warrant that experience. And I felt incredibly sad about that. And I towards the end of my PhD, I started to have much more interesting scientific problems. But I worry speaking to lots of students who perhaps their PhD is like mix these 30 different chemicals in 100 different ways in the lab, that they have not been given a sufficiently interesting prompt during their PhD or enough design space to think, I'm going to have to really think deeply about this problem. I can't just grind through it. It won't get me anywhere.
Anyway, yes.
Otherwise, you've really missed out on an opportunity, I think. Not just with the
Correct.
magic mushrooms, but with your PhD in general.
No, that's such a valid point, especially about PhDs. Sorry, Alice, go ahead.
Yeah, I was going to say, do you think that if students don't have that, let's say, bigger picture of this is why I'm doing and spending all of this time, learning, research, spending time in the lab without a clear, this is what I'm doing for, that they kind of then redirect their careers? Do you think it has an impact on their careers or their specialisms or their areas of
I
expertise?
don't know, but I strongly suspect it has an impact on the quality of their final thesis.
Experience.
I think that there's like a natural trajectory in a PhD that would ideally be followed in most cases, where by the time you are in your maybe final year, which in the UK is quite early, is like in your third or fourth year, that you should be able to carry on even if your supervisor went to the moon. And I think the driving force in that capacity to carry on is that you've got really good research questions. So instead of just, my PhD is to mix these chemicals together, my PhD is to understand whether this thing can, measure this thing based on this particular effect using this technique. Like they can become very specific, but also to have some overarching questions of, what is the chemical that will best modify the degradation
Yeah.
performance of this battery given these constraints in a particular setup. Like, I think that research questions are the kind of like lifeblood of PhD research. And I will often see people get to the sort of 9-month stage and they still don't have any questions that they're trying to answer. And that's very understandable because often they are busy learning techniques. They're busy learning how to make a sample. They're busy learning how to characterize or to write some code. But I think it's the root of a lot of later stage anxiety that they have still not got ownership of their project because they've not really worked out a core set of questions that they're trying to answer. And I think that sense of ownership is the path to freedom and some degree of calm, because you think, okay, I really, this is my thing and I can push it in different directions because I understand what we're trying to achieve.
Yeah.
I want to ask, maybe move us a little bit forward as well to, so you finished your PhD and I'm guessing you went into becoming a postdoc and then, and continued that path. And at the same time, you worked on, you're working on, I think, a startup as well, another organization, which we will, of course, discuss. I would love to know a little bit more about that as well. What I want to, if you don't mind, to ask is that transition. You were at a crossroads to go one way or the other. Battery, as you said earlier, was coming up topic, in different in automated cars or manufacturing or whatever it is. It was at the time it was booming. It was started to boom. And how did you make the judgment to go one way or the other while and once you decided, so this is probably a two-part question, so what made you choose that path, and or what was your thought process, as it were, and then once you started to go down that path, like the thing that you talked about, like the way of thinking, how to look at a problem in a more overarching way, look at the use case, how did you manage to absorb those kind of ideas, which are probably coming from practical industrial side of the world? How did you manage to get that into your, let's say, system to think about things in that way?
Right,
That's
right.
a long question. Apologies.
It's a
I
long
hope
question,
I
but
made
I think
sense.
I got the drift. So towards the end of my PhD, machine learning started to appear a little bit more in the news. So this is like 2014. So 10 years ago, I think there was a significant uptick in like media stuff about AI. And around that time, Professor Andrew Ng from Stanford released his now very famous introduction to machine learning course on
Yeah,
Coursera.
on YouTube. Yeah, Coursera or YouTube as well, right? It's brilliant. I've done that. Yeah.
So a group of my friends from undergraduate, about 10 of us in a WhatsApp group, all just said, hey, let's do this course together. Like, it's 10 weeks long. Let's just all do it. And I think in the end, maybe 3 of us ended up finishing it. And
Oh,
I'm now a, you know, reader or associate professor in artificial intelligence for materials design. One of the other guys is, a director of data at a major battery manufacturer, and the other guy like sets up companies that do machine learning. So like the impact that
yeah.
course had on these 3 people, it's really changed the direction of our careers. It's really incredible what Andrew did by setting up that course. And then that's the peak time when I was like, God, I wish I'd done computer science and not mechanical engineering. Like, I really felt it very strongly at that point. But I think maybe looking back, that didn't actually matter so much in the end. But I did think I've done the wrong PhD. I know I've already made the mistake once of not doing AI. I'm not going to make that mistake again. I should quit this PhD and go and do a different one. Crucially, I should say the first year of work in my PhD did not appear in my thesis because I was setting up a silly experiment that didn't make sense, that didn't answer a question. And it ultimately didn't work, and I threw it all away and started again. So, like, if anyone's currently going through that process, don't worry. It's not as uncommon as you might
It's
be
okay.
thinking.
Yeah. Yes.
People don't talk about it enough. But yeah, so
Yeah.
I realized I wanted to do machine learning kind of instead of what I was currently doing. And I went to speak to Professor Murray Shanahan, who's a professor at Imperial. And that's, one of the luxuries of being at a top institution. There's lots of amazing people you can go and speak to. And he very kindly gave me 20 minutes of his time. And I basically said, look, I've made a mistake. Did the wrong PhD. I want to come and do a PhD in your group. I just recently read his book. And, what do you think? And he said, Dad, don't do that. That's a mistake. You're so close to finishing. What you should do is, capitalize on the investments that you've already made, and then try and move sideways into the place that you want to be. And that turned out to be fantastic advice, and is exactly why I am where I am now, which is very happy with the job that I've got and really enjoying the research that I'm doing. And so, yeah, that's again speaks to your kind of one of your first questions. It's like, I think the path is not so important. You can really get a lot from many somewhat parallel routes, as long as you keep trying to nudge yourself in the direction in which you are interested and you think will have a positive impact in the world. Then I think you'll probably get to a good place with lots of luck in the interim as well.
And
Awesome.
did you feel, as you're going through the journey of becoming, after following your PhD, going into the next steps, did you feel that you were like, because maybe this was a few years ago, how did you get in industrial experience as a part of that,
Sorry, I
and
missed the second
how
question.
important?
I've got it back now. So I actually did a 3-month industrial placement during my PhD with a company that was a spin out from Imperial College, Series Power. And then it's so interesting to go into industry from academia because it's just so radically different.
Mm.
And there are all kinds of advantages, like, you're directly making products that can impact the world, and the work is much more structured in many ways. But I think as someone in your mid-20s, it can also be quite boring by comparison because you're not given this huge freedom to kind of look at anything that you think is interesting. But it gave me a sense of like how straightforward, not simple, but straightforward some of the problems industry are facing. Like we just need to use less of this material. Can you work out a step in this long workflow that would allow that to happen? And it's quite unromantic compared to a lot of the questions that academics are trying to answer, but has consequences in the billions of pounds and could be the life or death of a particular
Mm.
device. So that was a really helpful foundational experience. I then did a few industry sponsored research projects in the first year of my academic job. So these are sponsored by Innovate UK, along with some collaborators at Imperial, people like Billy Wu and Greg Offer. And they, again, really helpful to see the like kind of gritty minutiae of industrial problems. And like, we just want this to be, can it just last an extra 1 month or whatever? And then that would cost all kinds of savings or things like this. And yeah, very helpful to go to a dusty, kind of old machines, ancient factory, there's oil everywhere, and they're making this thing. And then you go back to your lab and in your computer model, there's no dust. There's no there's no partially broken machines, there's no oil on the floor. Just the massive disconnect between what it is you're doing intellectually in an academic context and what's going on in industry for some of us is really helpful to be reminded. I mean, it should be compulsory. You should get chucked into a factory for a week once a year to remind you of just how different
Absolutely,
it is.
totally agree with that.
Yeah.
The reason why
It's
I
difficult in
kind
the
of
UK because we don't have many factories. But
right. The reason why I wanted to ask that was that what I found speaking to certain like master students or PhD students sometimes, that they were so worried about, let's say in machine learning, worried about getting a percentage increase in whatever the accuracy, and they would say we would use neural network versus this other method, something else. But my question when I ask why are you doing this, what is the actual goal, they didn't even understand the question, right? Because when you go into industry, the whole point is there has to be, at least at the end of it, there has to be a dollar value
yeah,
associated
right.
to most things,
Yeah,
which may be not the same as in academia. I guess get that because they are done. There's a different purpose for it, but having that mentality of understanding why that's done and how that might be associated to work you're doing, plus of course at the end of it the monetary value, the monetization component, that is quite an important thing. And as you said, I think maybe the way that our academic system works, the only way to get that, I think, is you need to put your nose into something that is industrial, and as you said, get some oil over
real.
yourself.
Yeah, I had an exercise that I did that also really helped. I'd encourage everyone in batteries to do, but I guess everyone to do is, can you make a spreadsheet type model of the thing that you're studying? Like, do you understand enough of the big picture numbers that you could reconstruct the most simple model? So for a battery, I had the rows would be each layer inside a cell. So like the current collector, electrode separator, electric current collector. What are they made of? How dense are they? How much energy could you store given these different thicknesses and densities of materials? And then how much can you wrap into a can, and therefore how much does that can weigh, and then what's the energy density of it as a result? That building that spreadsheet is a relatively pleasant afternoon's work, but you come out from that experience with a really satisfying connection across the kind of length scales and between the chemistry and the technology, that I think leaves you in a very strong position to, for example, answer questions at a conference, right? Someone watches your talk and say, well, what about this big picture thing over here that you haven't mentioned? And you can say, oh, well, I see how that relates because I've got this spreadsheet in my head that I haven't learned, but I have understood. That gives you, a huge amount of confidence, then engage with a much broader conversation, which I think is so helpful.
Is that spreadsheet or the equivalent of that spreadsheet, is that something that you then use for yourself? Do you share that with the team so that you're all speaking the same language or everybody works from the same data? How do you, because that's a great way of standardizing knowledge as a foundation to build things on, right?
Right. I have shared it with lots of people, industry and academic, but I also have encouraged many members of my group to make their own, as an intellectual exercise. But this concept of building foundations to share knowledge, that is something that we're really passionate about as a group. And we try and make sure with every paper that we publish that the code and the data comes with it. But more than that, that they're in a very accessible format. So a really nice example of that recently from the team is a website called microlib.io. And you can basically just go there and there's 100 different microstructures and they're all very aesthetically pleasing because they're little spinning animations of them. But you can download the data, an expansion of the data, videos of it, the code that generated, all that stuff is just there as part of the deliverable with the paper. And I think that way of doing science, although it's a bit of a pain because it's a lot of additional work to get to that level, means that you are building a foundation brick that someone else can build on top of. And I think
Yes.
so much scientific work ends up being a sand brick where once the PhD student leaves their PhD, no one's ever going to run that code again because it's not doesn't run. And it's not necessarily a complete waste. Hopefully that PhD student got a lot of good training during those 4 years, but it hasn't necessarily contributed any additional science blocks to the civilizational structure.
And it's
Feeling
just a
of
waste of opportunity for knowledge share, right?
Right.
It's like if
Yes.
only one person can manage the models of code or etc. Whereas if you transfer that to people that could use that to further build, it would significantly accelerate probably
Absolutely.
the work
I
and
think
the impact
these
they
sort
have.
of large language models and co-piloty type things are going to really help with this, because the problem is not so much about laziness. It's more about the fact that it's not, I don't know how to build really fancy websites that do all these things. I need to go and ask someone. That's a lot of work, and it requires me to tell someone that I don't know, which I think a lot of people doing academic research struggle with. And so having resources that can say, here's how you build a website, and here's how you share your data, and here's how you put it onto a bucket, and all this stuff, I think that's going to be really impactful in science in general, because it will give people the confidence to do things that otherwise are a bit out of their current knowledge frame.
And the Git, the data from the Git and all the links will be also available on the show notes. So if anybody want to go and check it out, we would definitely encourage that. Please also tell us about your chief scientific officer role a little bit as well, and what you do there. Maybe that might be also a really cool thing to kind of spin off from here.
Yeah. So a year and a bit ago now, two of my fantastic PhD students, Isaac Squires and Steve Kench, came to me saying they'd be really keen to spin a company out of the group, with Isaac as the CEO and Steve as the CTO. And I think some interesting context there for maybe other people, maybe in a similar place, is that Steve and I'm very happy in my job in academia, and Steve loves doing science. And I think he and I have both said to each other many times, if it wasn't for Isaac, we probably wouldn't have done this. Not because it, wasn't an awesome idea, but because we're not the people who are going to drive a business. Like it's a whole way of life, I think, as anyone who's had a go at this knows, to drive a business forward. But Isaac was super keen to do it, and he's also amazing at it. And so between the three of us, we had, I think, all the components necessary to get this thing going. And so, yeah, that's been going for a year now. We've raised some money and won some prizes and some grants, enough so that we've got some offices in Shoreditch, and we've employed some people, and basically we're building. We're in the process of building, and that means that we're just about to enter a stage where we work very closely with a few select sort of target customers, big manufacturers, to say, look, here's a kind of early version of what we're building. We'll let you have a go. And we're going to solve your problems, but you need to give us some feedback about where you want it to be better. And that's a very standard part of your cycle as you're building up a business. But it's really exciting and also quite stressful, because it means that people are seeing this thing, it better work. Yeah, so that this is Polaron. You can go and check out our website at polaron.ai. Just so much learning between the three of us in the past year and a bit, where none of us knew how to start a business then. And so many small pieces, boring things like tax and equity structures, but also like, what is your product precisely? There's lots of cool stuff that we can do and lots of problems that we know that industry has, but how do you connect those two things together that is a legible product, like an interpretable product? How do you come to someone who's going to sign this purchase order and say, this is what we're selling you, and it's going to make your life easier for these reasons, in a way that they're going to be able to understand and justify that expense? It's very different from anything in academia, really, and it's absolutely great fun as well.
I mean, it sounds like you have a very complementary team, right?
Yeah.
You have a CEO, you have yourself. You all have a very strong scientific background, but each bringing immense value that form the foundational blocks of a startup, right? So
we were very lucky
I
that
think that's what people.
We found a head of engineering who's fully built an AI startup before, so he can do full stack development, and he's done the whole journey.
Yeah.
So really, we've been very fortunate, and I think part of that good fortune has come from having an exciting idea in a very exciting space. Like, do you want to come and work at an AI startup developing advanced materials characterization design?
Yeah.
I think a lot of people do, right?
Yeah.
So
very, very cool.
Just one last thing to talk about it. We will move on to the next steps. Just to ask, in doing the startup and all the learnings that you had in the past year versus your academic career so far? And I know it's a spin-off, and there are of course huge amount of scientific input that you need to put into to doing that, of course. My question is, if someone, because I know some people after finishing their PhDs might want to go and start to do on your own thing, or at least try, right? Would you recommend to kind of give that a go at that time, even though maybe you don't have that much of an experience? Maybe fail, but it's okay to fail in that time and then just see how it goes, versus maybe have a bit more process experience, do stuff a little bit, be exposed to the world a little bit more, and then
Find the
move
right
on.
team, find people
Find
in
the
the
right
right
Right, find the
team.
right
team.
team. How do you feel about that?
I think there's definitely no one size fits all solution for this kind of advice giving. I would not recommend the exact path that we've followed to everyone that I've seen in the academic space, because there's such a range of different characters and skill sets. There is significant degree of privilege in what we've done, in that we've been able to afford to do it, right? So, we had to afford some initial legal fees and afford some periods of time at the start where Isaac and Steve weren't being paid. And those things are all, marks of privilege that we all are aware of. Not everyone, especially people with caring responsibilities, are able to just suddenly not make any money for a period of time.
Yeah.
So they might well be better off going to industry, getting a good, healthy salary, and also learning lots of skills and understanding about the way the industry works before taking this kind of crazy risk of starting a company. That being said, we did go down the venture capital route. So our money is not our own. We're not investing our friends and family money in this. And that's because we're making, an industrial product, and we want
Yeah.
networks of major
Absolutely.
industrial products.
Absolutely.
Yeah.
Which means that de-risks it significantly, right? Isaac and Steve now pay themselves appropriately, and we get to focus on the work in proper offices. I think for some startups where people are working out of their attic and may not be able to pay rent in 2 months' time, that's a very different game, and not one that I would encourage many people to play. I think that's
Absolutely.
quite a, yeah. But if you are going to play it, you probably want to play it when you're 25 and not when you're 45. So yeah.
Yeah.
Take risks early,
Yeah.
learn from the learning,
Or you've got any
and then
responsibilities.
become successful by the time that you're 45.
Yeah.
Absolutely.
Huh?
Yeah, we can move on to the next, understand like what's next, right? What's next?
Yeah.
Yeah, what's next? What, of course you've come this far, done amazing things, a research leader in your space and a thought leader. What is next for you? What are you kind of most looking forward to right now?
So I feel very blessed because I love my academic job, right? It's a really wonderful job where it's hugely varied. So I do, some days I'm teaching, sometimes I'm an admissions tutor, some days I'm a personal tutor hearing about, your students, personal problems and trying to help them with their life. Other days I get to go to, huge consortium of European scholars. Everyone's at the cutting edge of what they're doing, everyone thinking about how to do the next big thing. That kind of variation is not, I think, present in so many jobs. And then in parallel to all of that, I get to work at an AI materials startup, and I try and do roughly 1 day a week or 1 day a fortnight with those guys. So for me, it's very much carry on doing what I'm doing because it brings me so much joy. In saying all that, I become very aware that academia is not great for everyone, right? And I appreciate that it's a real source of misery to some people because there's so much randomness involved. So I think it's something like 1% of PhDs ultimately get to become academics. And I know from the inside just how much luck there is in that. You've got to have a job become available for a start, which, they are not available very often. And in some countries, a professor has to die before another one is employed. It's that severe.
Mm.
And so having a career where you are really at the mercy of the gods as to whether you get to progress to where you would like to be is a very stressful thing. And it becomes somewhat like the arts, where my friends who are musicians or actors are at the mercy of the casting and recording gods as to whether they get to do what they want to do. and
Yeah.
that's stressful for them. So I think academia is wonderful if you're also really good at rolling sixes, which of course no one is. But some people, I think, often suggest that they are really good at rolling sixes once they've already rolled a six. So there's a degree of sort of survivor bias about just how good academia is. I think the other thing maybe to highlight there is part of the reason that I feel like I enjoy this job a lot is because Imperial, as an employer, does not make you do anything in particular. So I have a huge amount of freedom. And if tomorrow I wanted to research something quite different, I can't imagine my boss having any problem with that. I wouldn't even ask him. I'd just say, this is what I'm going to do next week, and say, oh, good for you. That is, again, another extraordinarily nice position to be in. But it does mean that there's a degree of pressure on you to deliver. You can do what you want, but it better be good. And that's, I'm very happy in that setup. I find it very exciting. And as a group, we're moving towards large language models for the automation of science. That's our kind of new area that we're trying to make a beachhead on.
Yeah.
And that's really fun.
That's a sentiment that was reflected also by Professor Calvo. I'm sure you know him from the same group as you, I think.
Rafa Calvo. Yeah, right.
Oh, yes,
Rafa,
yes,
yeah.
It's from the same department.
Yes, and he mentioned exactly the same sentiment about the university and the department as well, where you encourage, so the social impact is something that is prioritized over publishing in this publishing 100 articles over a period of time.
Definitely.
So that's a incredibly different mentality to have. Many of the traditional universities that might be not the case. So I think that's something that should be appreciated as well. However, at the same time,
go for it.
No, I was going to. At the same time, it's putting responsibility onto the researchers to say you need to deliver, right? So it's like what he said was you need to have autonomy, you need to have connectivity to other people, and also you need to be able to have cognitive empowerment. So effectively, you're given the autonomy to do whatever you want within reason, but at the same time, you need to deliver along that line. So that's a interesting and a very cool way of looking at the world, I would say.
Absolutely.
Awesome. Well, again, we have a couple more minutes, I think.
I'm glad that we managed to end
We're
up
always
in a
very
philosophical space by the end.
yeah. No, I mean, listen. I think Sam, to hear about your journey and the way how you got to where you are, the way that you work, the support that you get from your institution, the inspiration you get from your colleagues, and moving in different fields, and you're a great example of somebody that's taken their strengths and their experiences and learnings and designed basically a professional career to your liking, right? I mean, very, very rarely do you hear somebody that speaks so enthusiastically about, what, I wouldn't change anything. I'm super happy. I got this, this, and this, and
I should then
I think that,
it's probably my responsibility to put like a little asterisk as we come towards the end to say that like
Yeah.
I'm naturally a very enthusiastic, optimistic person, as I'm sure you can tell. But there are wolves and monsters and obstacles along the way, which I haven't talked about, but my colleagues know that I do talk about fairly often. There are, abusive people, and there are abusive institutions, and there are perverse incentives that cause people to do publishing 1,000 articles but not actually making any impact. No, these things all are super real and pose massive obstacles and drain people's, emotional energy along the way, and often will lose a lot of great scientists because they had an abusive supervisor, or because their department didn't support them for no good reason. This stuff is real and has a really negative impact on science. But I think people are aware of it more than ever before, and that there are avenues through which you can report some of this stuff more than has been historically available. There's a huge amount of work still to do, and I think everyone in academia will know of some like totally wretched professors who are, making up results or abusing their students or whatever. This stuff needs to stop, but it's, I guess, a very old problem, how you wrestle with people in power. They might be a very good scientist, but they might be an awful person. How do you reconcile those things? Yeah.
Please, like, don't assume that we think that everything is rainbows and butterflies. Thanks for qualifying as well and clarifying, because it is good to know that no matter how good everything is and seems, and you could have the best job in the world, there's always going to be challenges, people that are blockers, luck
Politics.
or lack of that,
Right.
politics.
Yeah.
I think this is a question that we always like to end the podcast with. And you mentioned a couple of big names throughout, but we like to ask always, if there were maybe one or two people across your career or even today that that you would really like to thank, who would they be and why?
Perhaps you didn't
Right.
have the time to do it like in person, maybe, because you
Yeah.
just
Oh,
happened. Yeah, yeah.
that's a very sweet thought. I mean, I mentioned this master's project supervisor, Fred Marquis, and he's just notorious as an incredibly nice man. Anyone who's done that course in mechanical engineering will remember Fred as like not only an
Yeah.
excellent lecturer, but just a really nice person to interact with. And it was absolutely him who got me started. And there was no guarantees that I would have gone into research at all had I not really enjoyed doing a summer project and then a master's project with Fred. So I am very grateful to him, but I have told him many times already, but one more time can't hurt. And then, most recently, I have had the support of our VP research, Professor Mary Ryan at Imperial, for some of this, scary monsters politics stuff, right? Going through a very difficult situation, very unpleasant professor at a different university, having someone senior who is willing to take the time to say, I absolutely think you're doing the right thing and you should carry on doing it. That makes a huge difference. And I think for many people struggling with things, just hearing that someone senior thinks that what you're doing is important and that you should continue is an absolute game changer. So I'm very grateful to her for the support that she's given during some of the more difficult times in my career. And then the list is incredibly long, right? I'm grateful for so many people.
No, of course, that would be a podcast on itself, right?
But those have been two particularly important people in my career. But yeah, I'm very glad to be able to have a stage to say thank you to them from.
Thank you for that.
Well, Sam, it's been an absolute pleasure. I think Shirosh and I could have definitely continued this a lot longer than this hour. Who knows? Maybe there'll be a follow up. We'll see. But wanted to really thank you for your time and sharing your experiences, and wishing you all the best with your very exciting future projects.
Great. Thank you both so much. I did enjoy that a lot.
Thank you so much. Bye-bye.